All right, we're on the trigonometric identities and equations. Again, the hope is that you're attending lectures, you're paying attention during lectures, and you're understanding what's being presented to you. Right, after you go through this, the entire section 4, you should complete the web assignment, which is going to be the Math 120 topic 4. Also try to say something productive in the weekly discussion if you can. So what do we do? In this section over here, we reviewed the circular functions, something really kind of past material. We talked about a cautionary note about the way things are done, particularly with the sine squared or squaring any trigonometric function for that matter. We typically put the 2 on the function itself. What does it mean? The whole function is being squared. We talked about fundamental identities. We talked about Pythagorean identities. We talked about even odd identities. I know it's difficult. We went through all this. We talked about cofunction identities. We talked about simplifying trigonometric expressions. We talked about proving a trigonometric identity. We talked about solving a trigonometric equation. Yes, it was a lot of material. We went through a bunch of examples, and we outlined in those examples what you're expected to do. So like, for example, we did these examples over here at the whiteboard. If you're missing them or you're dozing off, you can always watch them in these little spot videos over here. It's really important that you do that, though, that you just pay attention to this stuff, you understand this stuff. Because what happens to a lot of students is they try to do things without understanding, and it's very costly. All right, so the bottom line, we went through a lot of material here. And then you get to the stage, again, it's a lot of material, I know that. You get to the stage where we start asking you questions to do on your own. So, I know it's a lot of material, and we worked through that. I want to get to the homework or the supplemental material. Because again, after working through all that stuff over there, you got to say to yourself, when am I going to chance to try? We want you to try. I mean, from day number 1, we want you to try. Now, certainly if you're watching my videos and you want to try while you're watching the videos, we would love to see that. We would love to see you try. All right. So, that we did a lot of examples. And probably, I think one thing nice about Essex College, or maybe it's nice, but it's also a bad thing, we do a tremendous amount of repetition and a tremendous amount of examples for you guys to get through. And of course, when I say repetition, it's really the same thing over and over again, identities, simplifications, and solving equations. But again, eventually we get to supplemental activities. Again, there's homework. What does that mean? You really need to spend a considerable amount of time outside of the classroom studying the material. All right, so I'm going to go through, one piece at a time, and I'll try to keep it simple. I'm going to go to the whiteboard, and I'll tell you what we're doing. Again, we're doing a supplemental homework on the simplifications. And give me 1 second to get my whiteboard going. Let's see what I'm going to do here. New whiteboard for you guys. And I'm going to share the whiteboard with you. All right, some people say, where'd the notes go? The notes are in your possession at all times. All right, so what are we doing? We're in section 4 of the notes. So section 4 of the course notes, and we're doing the homework. Now the homework is divided into parts. So I'm going to do one part at a time. The first part I'm going to do is the simplifications. Okay, number 1. All right, it says factor the expression. Let me write this down for you. Now I realize what students are saying, what do you mean factor that? Well, I'm going to point out for a lot of students, what I would tend to do is write things in terms of sines and cosines first. So it's going to be 1 over cosine to the 4th power x minus sine to the 4th power of x over, well, let's see what you get, cosine to the 4th power of x. All right, so I'm going to keep going. It's not a factorization, by the way. But let's write this over here. It's going to be cosine 4th power of x, and they get 1 minus sine 4th power of x. Someone says, why do you do that? Initially, I want to go back to really familiar things. And what are those familiar things? Well, the familiar things for me are going to be sines and cosines. Now I'm going to try to factor it because I did say factor in. And I'm looking at the top, and that would be 1 plus sine squared x, 1 minus sine squared x. What's on the bottom? Well, I'm going to write it as cosine squared times cosine squared. Okay. Now, what do I notice over here? I want to point out what I'm noticing. I'm noticing that 1 minus sine squared is related to a Pythagorean identity. Let me write this down for you. I'll put it in red for you. So sine squared plus cosine squared is equal to 1, which means cosine squared x equals 1 minus sine squared x. Let me put what I'm seeing. I'm seeing it over there. So what happens over here? This is actually, the 1 minus sine squared is actually cosine squared. So what happens over here? These cancel. And that's good news because it makes it much simpler for me to do the problem now. I'm going to go back and I'll write it over again for you. It's going to be 1 over cosine squared x plus sine squared x over cosine squared x. What's this thing going to be? Secant squared x plus tangent squared x. Again, I factored it and I simplified it. Let's look at the answer key and see what we're staring at. We're certainly staring at the same thing. Now, I know some people say, well, I want to do them differently. I'm not going to say you can't do it differently. The bottom line is you want to be able to do it. I'm going to do this a little bit differently. We're going to get the same answer. So this is still number 1. I'm going to write down secant 4th power x minus tangent 4th power of x. Well, I can factor that. What do you get? Secant squared x minus tangent squared x times secant squared x. This is factoring, by the way, plus tangent squared x. Yeah, for some students, it actually made it worse. But what do I now know? I know I got a Pythagorean identity. And let me write that down for you. I'm going to put it in red again for you. So I put this down for you. Sine squared x plus cosine squared x equals 1. I'm going to divide both sides by cosine squared. What would you get? Tangent squared. And we derived these in class for you. Plus 1 equals secant squared x. And what is this going to be? 1 equals secant squared x minus tangent squared x. Now, what do I notice? I notice this thing here is right there. It's really the number 1. So what do you get over here? You would get 1 times secant squared x plus tangent squared x. We're getting the same answer, and I hope you realize that. What path are you going to take? That's kind of up to you, but you have to realize is, no matter what path you take, they kind of land in the same spot each time, all right? That's considered simplification. We took a 4th degree trigonometric expression and wrote it down as a 2nd degree, and that's a substantial simplification. I'm going to go to number 2, and again, I want to emphasize here it's a simplification problem. This is cotangent of x times the secant of x. My recommendation to you is to write things in terms of familiar functions. I would say familiar function for me for cotangent, that would be cosine of x over sine of x. And secant is 1 over cosine of x. What's nice about this, although it's conditional, they do cancel off, conditionally cancel off. And what are you left off with? 1 over sine of x. And what's 1 over sine of x? Cosecant of x. Let's look at the answer key, see if we got it right. And yeah, we got that one right too. All right, let's go to the next one, which is number 3. And what does number 3 say? It says factor it. Well, let me write it down for you. This is 4/3. Yeah, certainly, and then use fundamental identities. We're trying to simplify these guys. And the fraction a little disturbing at this point, but let's keep going. 8/3 and sine squared. These are written to work, by the way. Plus 4/3 sine to the 4th power. Well, I'm certainly seeing sine, so that's helpful. What I'm seeing is a fraction, so I'm going to pull it out. It's 4/3. What are you left off with? 1 minus 2 sine squared. This is considered a factorization, by the way. I'm factoring out what's called the greatest common factor. And then what do you get? Plus sine to the 4th power of x. Let's keep going. This is 4/3. I'm still factoring. And I think I can factor it. When you get 1 and 1, I'm going to say sine squared, sine squared. All right? Minus, minus. Let's see if that works. You would get 1, then you get minus 2 sine squared. Yeah, looks pretty good. And what do I notice about this guy over here? Again, Pythagorean identities. So it's going to be 4/3 times cosine squared x times cosine squared x, which is going to be what? 4/3 cosine to the 4th power x. Put a box in this. Again, I'm not beyond making mistakes. I want to look at the answer and see what they have written down. And they certainly have that written down, all right? Now, someone says, is that a simplification? Yeah, I did have, 3 terms before, and I only have 1 term. That was not bad. Now, someone says, why are these things working out so nicely? We write them to work out nicely. All right, let me go to number 4 now. And I'm going to look at it, and it's a problem. And I'll tell you what the problem is. There's 2 fractions. All right, different denominator. So I got to get an LCD. I'll write this down for you. It's going to be secant x plus 1. Yeah, I'm going to put these in parentheses just to make sure you know these are arguments of the secant function. And secant x minus 1. What goes on top? 5 times secant x minus 1 minus 5 times secant x plus 1. Yeah, it's much worse than it was. But what do I now know? If I just expand the top, I'll write this down for you. It's 5 secant x minus 5 secant x minus 5. And if I expand the bottom, what do you get? You would get secant squared minus 1. All right. So far, so good. What's happening now is these 2 terms disappear. So what are we left with on top? Just a minus 10. All right. Now I want to remind you about the Pythagorean identity. Sometimes people say they can't remember. Well, I know that sine squared x plus cosine squared x equals 1. Now if I divide through by cosine squared, what do you get? Tangent squared x plus 1 equals secant squared x. So tangent squared x would equal secant squared x minus 1. Well, I'm seeing that. So what's the bottom? It's just a tangent squared. What's this going to be? Well, in the simple form, it's minus 10 cotangent squared x. Put a box in that. Again, I'm going to look at my answer key, and I want to make sure I'm staring at that as an answer. It's certainly simpler than what was presented to me. All right, let's go to number 5. And what's number 5? It says use trigonometric substitution to write the algebraic expression. I'll write this one over here for you. This is the algebraic expression. It's 100 x squared minus 169. That's algebra. But they say 10x is a substitution. And that substitution, 10x equals secant theta. So the first thing I want to do is, substitute it in there. But to do that, I realize I got 100x squared. So what would you have to do? You'd have to raise both sides to the 2nd power. Let me do that. What do you get? 100 x squared. 13 squared is 169 secant squared theta. So I'm going to plug it in now. That's going to be, 100x squared is 169 secant squared theta minus 169. All right, so I did my substitution. So let me read these. It says use trigonometric substitution to write the algebraic expression as a trigonometric function of theta. Oh, now they got something about theta between 0 and pi over 2. Well, I'm glad they did that, and I'll tell you why. If the theta is between 0 and pi over 2, every single trigonometric function is going to be positive, right? Every single one. It makes it a lot easier for me to do the problem. So I'm going to factor this guy and see if I can simplify it. 169, that would be secant squared theta minus 1, right? The square root of 169 is 13. That's not so bad. And secant squared theta minus 1 is actually just a tangent squared theta. Now, if there was no restrictions on the angle, this would be 13 absolute value of the tangent of theta. but there's the restriction is that the theta is between 0 and pi over 2. So I now know that this is 13 tangent of theta. A box on that. Get my little red pen out. And I want to see if they wrote that down as an answer. And what they write down, they did. All right, that's number 5. And now I'm going to go to number 6. Again, the hope here is you studied the notes and they're just reinforcing what's expected of you. What's over here? Cosine squared 54 degrees plus cosine squared 36 degrees. They say use the cofunction identities. Let me write this down for you. You know, the sine of theta is the same thing as a cosine of 90 degrees minus theta. All right, we derived those in class. So let's do that. Put this over here. So I'm going to write the cosine squared, 54 degrees. Let me write this over here first. Cosine, I'm sorry, I didn't mean to say that. I'm going to put it over here. Cosine 90 degrees minus 54 degrees. Sorry about that. And that's going to be cosine of 36 degrees. Would that be agreed? All right. So what is this really equal to? It's equal, I'm using the above identity, the sine of 54 degrees. Let me repeat what we did. We wrote down one of the cofunction identities here. I took the theta to be 36 degrees. That's right here. And what do you get over here? 90 degrees minus 54. All right. What's 90 degrees minus 54? Well, that's going to be, 36 degrees. That's pretty obvious. What's it equal to? Well, it says equal to the sine of 54 degrees. Let's write that down now. So I'm going to go back over here. And what do I have? I have, let's see, the cosine of 36. Let me write this over here. The cosine squared 54 degrees plus, I want to put on what we're looking at this now. What's cosine of 36 degree? It's the same thing as sine of 54 degrees. But what are we doing to it? We're squaring it. All right, now what am I seeing over here? This is a Pythagorean relationship that the cosine squared of an angle theta plus the sine squared of an angle of the same theta is going to be equal to the number 1. All right, cofunction identity. Let's look at the answer key, and that's what we're staring at over there. All right, let's keep looking through this. I'm going to go to number 7 now. Oops. And this is another trigonometric substitution problem. What do they tell me? They tell me the theta is between 0 and pi over 2. I'm thankful for that because that makes all the trigonometric functions positive on that interval. And they tell me the a is also a positive number. That's kind of a gift for me because these could be difficult if they're telling you it's not restricted, but these are restricted. So you get u squared minus a squared. Then they go on to say u is equal to a secant of theta. Well, I need to know what u squared is. I want to do a substitution over here. That would be a squared secant squared theta. Let me write that down for you. That's going to be the square root of a squared. This is the substitution, secant squared theta minus a squared. I'm going to factor it. And if I did that, what would I get? I would get a squared and secant squared minus 1. All right, let me push it up. I'm going to keep going. The square root of a squared, if a is a positive number, and they did make that statement, is just a. And then I'm left with this over here. All right, what's the secant squared theta minus 1? It's actually the tangent squared. All right, what's the square root of tangent squared? Well, it's actually the absolute value of the tangent of theta. However, these functions are positive on this interval. So we get a tangent theta. All right, put this in parentheses. Get a little red ink out, and I'm looking at the answer, and I'm seeing the answer there in the answer key, by the way. All right, let's go to number 8. Relatively simple questions. And what's number 8? Simplify. Let me write this down. This is sine of z over the cosecant of z plus cosine of z over secant of z. Well, this looks pretty easy to do because I want to write things in terms of sines and cosines. And this would be sine of z. And 1 over cosecant is another sine of z plus cosine of z. And 1 over secant of z is actually just a cosine of z. And again, these are written to work beautifully. What do you get? Sine squared z plus cosine squared z. Again, another Pythagorean identity, and that equals to the number 1. Let's look at the answer key. They got 1 down. By the way, these are conditionally true. I would not worry about the conditions under which they're true. All right, look at number 9. And again, for a lot of students look at this, they don't know where to start in the problem. I would start by trying. All right, I'll put number 9 down for you. And what do you get? You get cosine of y, and you get secant of y plus the tangent of y. Well, I'm not going to say this is the best thing to do, but it may be the only thing you can do. And I'm going to recommend what you can do is here, just write everything in terms of sines and cosines. Let me put that down for you. And secant would be 1 over cosine of y. And tangent would be sine of y over cosine of y. Now, by the way, this may be a dead end, and sometimes it is a dead end. But I'm going to write this down now. I'm going to multiply the top and bottom by what's called the minor LCD. You learned about this in math. I'm going to say probably 09-2, but certainly was reinforced big time in Math 100. And what would you get? On top, you get cosine squared. What do you get on bottom? 1 plus sine. Okay. Now, by the way, I'm not going to say that's the answer, but at least you did some work. I want to keep going. I'm looking at this thing. I'm starting to realize the top could be written in terms of sines. And what would it be? It would actually be 1 minus sine squared. And the bottom is 1 plus sine of y. I'm going to factor the top. You know what? I'm going to just push it up. Eraser out. We'll look at the key later. The top factor is the 1 minus sine of y times 1 plus the sine of y. What's the bottom? 1 plus sine of y. What's nice about this? There's a cancellation. Again, it's conditional, but there is a cancellation. If I don't worry about the conditions, 1 minus sine of y. Put a box in this. I'm going to get my red pen out and see if I got the right answer. And I did. That's the answer I'm looking at in the answer key. All right, let's go to number 10 now. Number 10, they're using a strange letter there. All right, there's a footnote there. We recommend you read that footnote. And that footnote is going to tell you what that letter is. It's the Greek letter gamma. All right, now granted, when I write a gamma on the board, it's not as good as a typeset gamma, but nonetheless, you can figure that out by looking at it. So I'll put down number 10 for you. And that's going to be 1 plus the sine of gamma cosine gamma, put these in parentheses for you, plus cosine gamma and 1 plus sine of gamma. Well, again, the letters might disturb you, but common denominator, what do you get? Cosine gamma times 1 plus sine of gamma. All right, let's write this down. 1 plus sine of gamma times 1 plus sine. It's a lot of work, isn't it? Over time, you get much better at this. And what goes over there? Cosine squared gamma. Wow, that doesn't look good. Let's keep going through it. And I'm really interested in doing the top, by the way. And if you multiplied it out, what would you get? You get 1 plus 2 sine gamma plus sine squared gamma plus cosine squared gamma. What do you get in bottom? Cosine gamma times 1 plus sine of gamma. Let's keep going. I'm looking at this thing and I notice there's a Pythagorean identity here. It's right over here. Oops, I didn't put parentheses over there. That's going to be 1, and 1 plus 1 is 2. So we get 2 plus 2 sine gamma. What do you get in bottom? Cosine gamma times 1 plus sine gamma. All right, I'm going to push it up. And it's a lot of work. We're encouraging work, though. I'm going to factor the top. 2 comes out, and you get 1 plus sine of gamma. What do you got in bottom? Cosine gamma times 1 plus sine of gamma. What's nice, I'm seeing a cancellation. Again, it's conditional, but I do see it. So what are you left off with? 2 over cosine gamma. What's this going to be? 2 secant gamma. All right, look at the answer key. If you're looking at the wrong answer, something happened. I'm seeing it. All right, let's take a look at number 11. And number 11, sine squared, 61 degrees, plus sine squared, 87 degrees, plus sine squared, 29 degrees, plus sine squared, 3 degrees. Well, before I do anything, I want to point out, I'm noticing these things here are complements. What do you mean by that? 87 and 3 is 90, and 61 and 29, right? That's also 90. So I'm going to use the cofunction identities as they point out. I'm going to write these down very carefully. So let's write this one down. I'm going to do this over here. I'm going to write the sine squared as the cosine squared of the complement of 61. What's a complement of 61? 29 degrees. All right. We just did this one here. All right. I'm also going to write the sine squared of 87 degrees in terms of cosine by using the complement. What's that going to be? Well, 90 minus 87 is 3 degrees. We left off with these two over here. What do you get? Sine squared 29 degrees plus sine squared 3 degrees. I'm starting to see I have Pythagorean identities over here, and I'll point out what I mean by that. This and this, same angle, right? Like sine squared plus cosine squared, the same angle. Well, that would be 1. And let's look at this one. Cosine squared, 3 degrees, plus sine squared, whoops, let me get, that's a 3 degrees over here, is also going to be the number 1. What's 1 plus 1? It's 2. Yes, these are written to work. Put a little check there, indicating we'll do that. All right, so that was kind of a quick homework. And I'm going to, just break this into 3 equal parts here. So this will be the homework. And then when we come back after doing that, we're going to do the identities. All right.